This is compiler construction theory class, and today we are conducting the lecture 2, and today's topic is phases of a compiler. So the first phase of the compiler is lexical analysis. We all know that. So what is the purpose of the lexical analysis? The purpose of the lexical analysis is to identify the tokens. And now what is the token? Token is a set of actually characters. A set of characters which gonna identify a unit of information. Okay, a single token will identify a single information. Okay, what is a token? A token is a set of characters or sequence of characters which is going to identify a unique information. Okay. Now let's talk about the token. Example of the token. There are many types of tokens. Okay, we are gonna create. First one is keywords, identifiers, operators, and the special or the separators. Okay, we all know what are the keywords. For, while, if, else. These things are the keywords. Okay, and now the identifiers, the variable name, the function name, which we are going to set are the identifiers, right? So these are also tokens. Operators like plus, increment, minus, decremental, all are operators. There are so many other operators also. And the separators, it's comma, semicolon, etc. There are brackets and other things. There are first bracket, second bracket. So all these are also separators or special characters, which are not tokens. The comment lines. Comment line is not a token, so we don't need to analyze that. Okay. Preprocessor header files are also not tokens. Okay. And if we give any command of new line, that's also not a token. These are this. These are not tokens. Okay. Now let's write a program to find out the tokens from that program. You guys try to find out which are the tokens here. Write the tokens. You don't need to write. You can write T1 equals to this one or this. Try to write. Find out the tokens. Okay. Skip this part. You can skip this part. Start from here. From here to here. Okay. Try to find out the comments. Sorry, tokens. As we all know, the preprocessor part is not the token. So we can skip this part, right? Yeah, that's why I have written this one. Skip this. Analyze this one.
Actually, int var equal to this is the token.
No, try to find out the tokens. Every set of characters or sequence which is representing an instruction is a token.
How many tokens I will have?
Okay. Let's try first. Okay. Skip this part also. Okay? Skip this part and this part. And now try to find. Hello. It will be another token. It will be.
And flow down.
Okay, let's do it. Right.
Six.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, correct. There are 16 tokens. Number of tokens? Close to 16. So, you're taking it, right? It's that easy. So, when you are gonna write a code, we need to find out these things. So, in our lectures, we are going to try to find out the tokens. We have already started. We started to neglect the command line. Okay. Everyone done?
Yeah.
Okay. Okay. If I give anything like this in the exam, always keep this preprocessor part. Always.
বাংলাতে বললাম সিআউট কি জন্য বাদ গেল তাহলে
Okay. This is from the STL. I will let you know that later. Okay, try another one. I'm writing the code. Try to do it. Okay. Let me tell you one thing. See out in this part, these two are different. These two are different. Okay? These two will be different tokens. Okay, now you can count. I'm going to tell you next. You can count. These two will be different tokens. See out.
Twenty-seven.
Sure.
Am I সাম সহ এটা হ্যাঁ এটা
There are 4.
$27.
Sure?
I'm sure.
Okay, let's do it. First one is int, right? Then main, and the bracket close, segment start, int a equal
20.
13,
20.
sorry, 20, comma,
Comma.
and b
Equal.
equal
30.
30, semicolon. Okay, then C out. Have you completed C out?
No.
Okay, because I was going to explain this one. You need to take this CR1 token, this is one token, and this is the another token. There are 3 tokens.
28 বলে তাহলে এখন এটা 28
Okay,
তাহলে
C out, arrow, arrow.
এটা পুরোটাই না
No. There are space. So this is one single. This is one, another. Like this.
সামনে আগে তো ম্যাম তাহলে এই দুটেই আছে
দুইটা সেমিকোলন
ওই দুইটা
It's not semicolon. It's quotation. It's not a separate one. It's not a separate one. Sum of a and b
34টা
arrow a plus
33
b return 0 semicolon bracket close. Okay, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 23, 24, 25, 26, 27, 13, 32, right? Then 32. Yeah. The number of tokens are going to be 32. Okay. This type of in theory class it might not come. Okay, exam. But we're learning this, analyzing this, so that we can perform this in the lab class. Okay. Okay, it may come. I don't know. So you're getting it right? Okay. Okay. In the previous class, we talked about the syntax analysis and the semantic analysis also.
আগেরটা তো পিসি অফটা ধরবো বলে
Yeah. Then it will be it was 7. In previous one, what was the number? Token number. 16. So it will be 16, 17, 18, 19. It will be 19. Yeah. Okay. So listen. So in the previous class we learned about the lexical analysis, semantic analysis, and syntax analysis. Okay. So I actually cleared the lexical analysis today. You guys are clear, right?
Yeah.
How to find out the tokens. Okay. Now we can move on to the next topic. Do I need to recall the syntax analysis or semantic analysis? Do I need to recall? Sure. Okay. Then let's move into the next word. Okay. In our phases of the compiler diagram, there are 2 things besides. This was the diagram with 7 layers, but here there was a single table, and this side there was an error handler. Do you remember that? Actually not. Let me try. Okay. Let me try the figure. Yeah. This was the table. Actually, okay. There are two other options, but besides this, all were connected to something else, and that is called the no. It is called the single table. Single table manager. It is single table manager. Write this one. This side it will be single table manager, and this side it will be error handler. These two things are very much important. Done? Just remember, with the main figure, and one side it will be a single table manager, and other side it is going to be the error handler. Just remember that. You already know the figure. There are two more steps. Okay. Don't forget that. I haven't found it. Then, what is the purpose of this single table manager? Okay. When we are taking the inputs, we need to store the things, right? The main purpose of this is the storing the data. The single table manager actually stores the data. It can be any data. It can be keyword, it can be identifier, it can be variables which we are giving, the values, number values, alphabetical value, strings, everything we are going to store here. Even after the tokenization from the lexical analysis, that also going to be stored here. In every stage, first the source program will come, okay, here. Then it will go to the lexical analysis from the single table. Then after the lexical analysis, the tokenization, it will again come to here for the same. Then it will go to the next stage. So it's coming and going, coming and going. Its main task is storing. Storing data. Okay? Okay. You understood that one, right? Single table manager. Now the error handler. In every stage, we have seen that in semantic analysis, we found an error about we needed to convert the integer into the real number. It was an error for the compiler because the compiler wasn't understanding that all the tokens were in the real value, but one token was in integer value. So the compiler got confused. It is also an error. So that was also found by the error handler. Error handler handled that. Okay. So what is the main purpose of the error handler? Error handler's main purpose is to identify the errors. What error is happening in which step? Okay. In different step, it finds different errors. Okay. It can be if there is any mistake in the comment line or the non-token things, it will be found. It will found it for the lexical analysis. For syntax analysis, it can be problem in the graph tree actually. For the semantic analysis, it will find the data type problem, which we found out already. So these two are the very important thing for compiler: the symbol chain manager and the error handler. I can tell you to write the advantages of these things. It's important. Characteristics also. What is the characteristics of the symbol chain manager and what is the characteristics of the error handler? If you know the characteristics, then you can know the advantage or disadvantage very easily. Okay, so we have completed the analysis part. Now we are going to enter the synthesis part. What was the synthesis part's steps? Do you remember? Steps. Help me find it out. Okay. So do you remember? Forgot? Okay. Don't worry. You can tell me that.
Intermediate code generator, code optimizer.
Yeah.
Code generator or code generator optimizer two actually machine
Yeah. So we learned only about the optimizer. We are not going to do it two times. Okay. Code optimizer. And the final one is code generator. Yes. So already our string or given string or the code has been tokenized. We have made it as a tree, root tree and the child tree, and we also have corrected the data type problem. So semantic problem done. Now,
tree task it to the access only in this case.
yeah, I will. Okay. Now the intermediate code generator. After the tokenization, we need to complete the tasks. Like in our previous token, we have written position equals to rate plus ID into 60, right? It was like that, something like that. Okay. Now as we have tokenized these things, now we need to perform the words, right? Like these operator things and this. So first, which was the priority? First priority, the plus one or the multiply one? Operator. Multiply. Yes, multiply. So first we need to do this multiplication and we need to store the data. Computer is very much slow to understand things. We need to tell him everything what he needs to do. We know that we need to do the multiplication and we can write the multiplication value easily, but the computer cannot store that. Computer need to use a variable to store that data. Okay. So what will be the intermediate code generator for this one? Okay. First, from this semantic analysis, we know that it is converted into the real number. That will be the first thing. So the first thing will be, we'll take the temporary variables. The first temporary variable. In first temporary variable, we need to store this data. It was in the real number, but sorry, it is a number. Now we need to convert it into real. Int to real. This 60 value. So this is the first task done. It is storing temporary number 1. Okay, next we need to multiply this, right? So can you tell me what will happen here? Okay. As this 60 is saved in here, we just need to multiply ID 3 with this temp 1. We need to follow this step. After that, we need to do the addition. Okay, this value is saved in temp 2. Right here, we just don't need to use call another value, because look, it's position. It's a single one. We don't need to store anything extra something. We can directly store here actually, like position equals to temp.
Rate.
So rate plus temp 2.
Rate plus temp 2.
Rate plus temp 2. It's done. If you want, you can call another variable like temp 3 equals to rate plus temp 2, but it will increase the complexity, right?
Yeah, but
extra single line. Yeah, extra single complexity. That's why we are going to skip that part. We are directly going to write the position equal to rate into temp 2. It's easier, right? This is the intermediate code generator. We are still in the phase of the compilers. We are learning how the compiler is working step by step. Okay, you understood this one, right?
Yeah.
Now the code optimizer part. We need to optimize this code. Why do we need to optimize any code? Can anyone tell me?
To make it work more easy.
Yeah, to reduce the complexity, space or time, anything. Yeah. Okay. So, look, here we can do these two things in a single line. Can we? These two things can be done in a single line. Converting this into the real, the 60, and multiplying it with the IT. We can do it in a single line, like this. Temp 1 is equals to ID multiplied by. To convert it into 60, into the real, it will be like this, 60.0. I already have shown you this, right?
Yeah.
60.0. So, ID will be multiplied with 60.0. If we multiply it with this, then it is already converted into the real. Okay. So it's done. Two lines are done in a single line. Get it? You don't get it? Okay. First, to do the code correctly, we need to convert this integer value 60 into the real value. You understand it, right? Okay. In our previous class, I have shown you that when we are going to convert this integer value to real value, it will look like 60.0. Do you recall that? You can check the pages. Okay.
Now in this case,
The very first class.
will be the same.
Yeah, in the first class,
Yeah.
I have told that. Yeah, it will be the same. outset. So if we convert a integer value into the real value, then a point value will be added here. That's it. Simple thing. 0.0 will be added. If you see this is not an integer value, right? This is a real value. This is the main thing. Now you understood? Sure? Okay. So, if we directly write this one like this, then it is already converted into the real value. So, we don't need to do this thing. We don't need to do this. Got that? This is the main task of the code optimizer. You still haven't got that, right? Okay, I'll let you know. But just point that out. To convert integer value into the real value, you just need to write it like this. 60.0 or this 30.0, anything. Point value will be added. That's it. This is the formula of converting the integer into the real value.
ম্যাম যদি এখানে পয়েন্ট থাকতো তাহলে
Then it will not be the integer. Integer doesn't have the point value, right? It's already in the real number, so we don't need to convert it again. Okay? Now, we just need to do this part. Position equal to rate plus temp. It's done. So one line is reduced, right? This reduction of one line is very much helpful for the compiler also. It will reduce a lot of complexity, space complexity, and we are reducing a variable, so it's definitely reducing the space complexity. Okay, have you done the microprocessor or assembly language?
Assembly language complete.
Assembly language complete. Okay. So this is done. Code optimizer part is done. Yeah, code generator. The code generator part is actually the assembly part, assembly language part, which we have done. Code generator. Which code we are going to generate? The assembly language, which the machine understands. Okay? So, what do you have to do now? Tell me something. Like, okay, do you remember the instruction of the assembly language? Move if, add if, these things? Remember?
AX, BX, DX.
Okay, move. First, we need to move this value. Yeah, so move this value in the register, right?
AX, BX, DX.
No, register. R1, R2, R to the R. Okay. Okay, we are going to use the R register because we are going to, if we are going to perform any operations, it is done in the register. Always. Okay. Now, what was the first value? Our first value. IT. Okay. We're gonna move that IT to our register 1. Okay. After that, we need to multiply this value. Okay. This value is taken to the register already. So now we need to do this multiplication. So we need to multiply R1 with the 60.0. Yeah. As 60.0 is a number, you need to put this number. This is a sign of number.
Number sign that will be
Yes, number sign 60, comma number. Yeah, integer value number. Number and are gonna store that where?
F টা দেওয়া লাগে না, ওটা তো ইউজ করি না।
Yeah, then if you are not going to use the move if, then how this value is going to store in the register?
আর শুধু মুভ ইউজ করছি। মানে ওই F টা তোমরা ইউজ করি জাস্ট মুভ
শুধু
তারপরে
move.
এরকম type।
Okay, there are so many versions of the languages.
আমরা ইমো X to X ইউজ করছি।
So it's not a big deal. You can use the F. If you have any problem, you can't use because there are so many versions. So it's easier. Okay. So already this is moved into the register, right? And we are going to just multiply this with the model and this value, and it's going to store in the register 2. The multiplied value will be
Register
stored
2.
in register 2 because register can store only one value at a time. It is already holding the ID value, so it cannot hold this multiplied value. So we need to store this in the second register R2.
Second register is 16 store করে then multiply apply করতে পারতাম না?
Yeah, you can do that,
Move
but
back.
that will increase a line. That will increase a line. Again, the complexity will increase.
আবার মুভ লাগবে, মুভের মধ্যে
Yeah.
For one.
Okay. Then after that, what we need to do? Tell me. Is this value is stored?
Addition.
No. This value, this rate is not stored yet. So we need to do the move again
Red.
and store this rate value into.
Arts.
Okay. We can use R3 or we can use this. This register is not needed anymore, right? Okay, R3. Let's do the R3 part. This is R3. Stored in R3. We have used R1, R2 and R3. Now we can do the addition.
ম্যাডাম ওই যে 60 সালে যে মাল্টিপ্লিকেশন করলেন
Yeah.
ওই আমাদের অ্যাসেম্বলি সময় তো বলছিল যে এই সাইডে মাল্টিপ্লিকেশন এটা ইউজ করার সময় এই সাইডে যেটা থাকবে সেটার সাথে এই সাইডে গুণ হবে।
Actually, okay, you can do that, but you need to store that somewhere, right? We are doing that in a single line, reducing the space and time complexity. As we already have optimized the code, now we are performing the code generator on the optimized code.
কিন্তু আরটুতে তো এখন কিছু নাই না ওই সেকেন্ড লাইনে
What?
আরটুতে তো এর মধ্যে কিছু নাই
Why?
The multiply করা আছে।
Multiply value will be stored in there too.
কিন্তু যখন আমরা মাল্টিপ্লাই ইয়াটা কমান্ড ইউজ করব তখন হচ্ছে এই সাইডটার সাথে এই সাইডটা নরমালি গুণ করছি।
No. It is using the register 1 value, first register's value. You are not getting it, right? Okay, let me tell this again to you. First, look, we have two values here. We need to multiply, right? So first we need to store one value so that we can multiply it with the stored value, okay? Another value. So move the ID into R1. We are using our register R1 to store the value of the ID. Now, in the another register, we are going to do the multiplication. We are going to store the multiplied value. That's why. As it is a number, we are using the number symbol with and we are going to store. As we have used this R1 register, if we use the multiplication, then it will automatically multiply with the previous register. It will automatically multiply with the previous register, and we are going to store that in the register 2. Okay, this is done. This line is complete, right? This multiplication is done. That's value is stored in R2. This temp 1 value is stored in R2. Okay, now for this line, we already have this value, but we haven't stored this one. For that reason, we need to move that red value R3. Okay, so the value is moved here. Now we just perform this addition. Addition of
R2 plus R3.
okay, it's done.
Rate plus
Sorry, rate is moved to the R3, so that's why we are using the you can write R3 plus R2. Both are same here. Okay. Now finally we need to save this number into where? Position. So we need to move the value into the position. Okay. We are going to store that value. We are going to store it in the position R2 into the position. As it is last, in the last, it will store here. It will be stored here. Don't you get it? Look, always we are writing this store. Store index in the last. Store index in the last. Store index in the last. So it is the last store index. So from R2 we need to move the position.
ম্যাম তাহলে R3 হবে আমরা তো উপরে লিখছি
R2 or R3.
না R3 টা R2 তে না আছে ওই যে
Which one?
add
Which one? Add.
Add if
We are using adding two numbers and convert it into this.
যোগ করার ফলে ওটা
Here,
R3 তে
here having R3 plus R2 equal to R2.
মানে ওটার মধ্যে রাখছি
R2 is storing the value of R3 plus R2.
জি
This line. So it is moved to the position. Our task is done. We have so many confusions, I know. It's a new thing, totally new thing. Oh, let me give you another to practice right now. Okay.
Ma'am, একটু তুলবো।
Okay, sorry. Good. Done?
Done.
Okay. Let me give you another. Suppose it is ID1 equals to okay, try to do this. Okay, which you have done the previous class, started from the lexical analysis. Okay, you may pause the video.
Asal